Today we're doing something slightly different to normal. What we're going to do is we're going to do a wee small project. Yes, in 1 hour. Just don't tell the architects how quickly you can design your... I have a little AutoCAD drawing that I've already created for the MasterSeries project. This is of a house extension, so I'm not going to go into too much details. And what we've got is we're extending this out to give us like a first floor larger area, and then the walls are going to continue up as normal here and here. So what I have done is I have created an additional layer where I have drawn my members that I want to import. So if I go to this and I just change that, I could, and it's just popped up over here, change the color, say to green, and say OK. And now you will see all of those members that are my structural members that I'm going to do are in green. I've just put them onto an isolated layer. So my first stage is to come along and save this as a DXF drawing. And I'm going to save it as a DXF, and I'm going to call it DXF2 because obviously I had a practice. And I'm going to save, and that's now saved that, and now I will just exit from the drawing and say yes, and we'll save it as drawing 2 as well. Why not? Okay, so our next stage is to come along into the MasterSeries 2017-14 from the 22nd of February, and I am going to import. Now we're dealing with PowerPad licenses, so I am able to import DXF. I actually can't import IFC. It should be grayed out. So I'm going to import a DXF file. And I placed it on the desktop so I can quickly delete it. There's my new drawing, and say open. And what I'm going to do is I'm going to bring in the layer called MasterSeries and nothing else. I'll bring in all the lines and polylines, and I'm happy just to put it into my U drive, and I will extract. So off it's going, looking through it, and it's found 12 members. And I'm now just going to load that frame straight away. And here I go. There is my basic outline of my frame. So what I need to do first of all, because I didn't draw this very accurately, is to tidy up some of the values and dimensions. So if I put my nodes on, you'll see where my nodes are. If I put my X values and my Y values, see there's a bit of alignment problems here and here and here. If I put, so I'm going to do some X-axis alignment. So modify, change, and set all to the common value. So those two are okay. I want to work with these two, and I'm just going to reduce the lines to fine. So I'm going to take these two values and I'm going to set the X coordinate equal to this. So very quickly I make those the same. Those are already the same, and those are the same, and those are the same. So that was the only X coordinates I needed to work with. Now our Z coordinates, because Z is our other plan dimension, is all jiggly-piggledy along here. So what I'm going to do is I'm going to come along and change the Y-axis coordinate, reset of all of these, and make them have a new, not Y, but Z, in fact, Z of, and I say proceed. So they're now all flush. And these are all more or less in the same line except for this one. So I'm going to do a reset. And I can just take the one I want to modify, but let's take all of them to ensure that they're all right, and then choose that as the new value. And it's a wee bit fine, so I'm going to say make it a meter exactly, and just rejig that about a wee bit and say proceed. and then these two here are outside each other. So I'm going to take this one and we'll make it 7.8 meters, and then I'm going to reset and take that and say proceed. So they're now all correct where I want them. Now my next stage is to put some columns in because I just have the first bit. So now I'm going to add some columns. I'm going to create columns, and I'm going to create these columns. In this case I'm going to be square hollow sections. Coming down and make these 100 by 100 by 3.6, and I'm also going to put them into come in at 2.5 meters high. I'm also going to add them into a member design group called columns, and this is something that's new to the PowerPad, in that with the 2018 version of the PowerPad we have upgraded its functionality to include the pro features of MasterFrame, and I'll talk about that as we go along. So first things first, we need to put a column there, and one there, one there, and one there. And now I want to look at my supports. So what I'm going to do is, so I'm still in that column, turn that off, go to restraints, static supports, is I am going to kill all the static supports that exist at the minute. I delete those, delete those. These I am going to make, they'll be fine, pin with a torsional restraint. I'm going to add in a second set, and it's going to be fully fixed because I will actually do the pinning at the ends of the members as I require them. So there's my 3 supports. So we're going to span from along here onto this one. So this member and this member are going to come onto this one. So now what I'm going to do is I'm going to put in my end releases, member end releases. And I'm just going to come down and pin all of them here and here. And you'll notice I'm getting something strange happening there, which we'll look at in a minute. So I'm going to have to come back, and while I'm here I might as well do these. See, that's looking at the whole length as one. So what I'm going to do is come into member split, and I'm going to take this member and I'm going to explode it into its component members and say proceed. So you got 1, 2, 3. Now this is one member, that's good, and that's a single, and that's one member. That should be a member from there to there, and that should be a separate member. So what I'm going to do is I am going to take this member now, so clear the selection, and I am going to explode, proceed. So that's one and that's one. Now I'm going to join these two together. So member merge, and one of the loveliest things is just what they call the quick merge from that node to that node. So what have we got? If we use the shorten, we will now see how our members are connected to each other, what are rail members and what are not. And what I do need to do is actually I need to put an extra member in there I forgot to put in. So I am going to go to create and add a member, and it will be a UC, and it will be probably something around the 152s. Let's work with the 152s initially and put that in there. So now we can come back and do our pins. So restraints, nodal member end releases. We've got that one. We need to put one there. Sorry, fully pinned there and there. That one's okay. Need to do that one, and that one, and that one, and this new one. So that's that model created from a member point of view. Obviously there are some more things going on to get the loading onto it, but those are essentially the members that I need to use. And the advantage of doing it this way is that we get the realistic deflections from this member loading onto this member. And this member being supported here may be stiffer than over here, so therefore we get a difference in the deflections. We also then are able to do the connection design automatically, and we'll be able to do our columns, our pad foundations, and our base plates all interactively. And that's why we don't do these one member at a time as 8 or 10, 2, 4, 6, 7, 8, 9, 10, 11 beams and 4 columns individually. What I like to do at this stage, because I've got everything here, is just to analyze it quickly. There's no additional loading other than self-weight, but this will tell me if the frame is stable. And obviously at the moment I actually need to put some properties, so section materials. I'm going to initially start off with all of the beams being the wee 102s. So I'm just going to copy that onto that one, put it in the front view, and all of those. So they're now 152 beams. The columns were defined automatically. So let's try analyzing again. And we have 3 unstable nodes. And say no. And I know it's here, here, and here. That's because these members here can't be pinned over both ends. We need to put a torsional restraint when we have a what we call a physical member that's got nodes in the middle. So all I need to do is go to restraints, end releases, and I need to take off the torsion on one of these two, one of these two, and one of those two. If I reanalyze, we should get a solution and results, graphical bending moments. Now this is very, very small resolution because it's only self-weights, but this gives me an idea of how the structure is working before I move on. So I can see that everything looks fine there. It's working the way I think it should work. And also from a deflected shape point of view, nothing is what I would call moving out of planes in any crazy. So now let's go and do our loading. Traditionally you would have come along in PowerPad and put the member loads in by going to member loading and put some loads on this member and that member. What I'm going to do is I'm going to apply area loading. That's one of the big new things from the MasterFrame Pro part of PowerPad for 2018. So all I need to do first of all under loading is go to default loading, and I'm going to use area loading, and I'm going to say my dead is going to be 1.5. So that's not my dead. What's my dead? It's 0.45, I think, if I remember rightly. Let me see. Yes, dead is 0.45 internally, and the live is domestic 1.5. We will worry about this bit here because this has just got a roof at first floor level because the building steps back in again for the upper walls. And that's all I need to do there. What I now want to do is to create my panels. So I can come along and start to create my panels. And immediately I come across a problem, and my biggest initial problem is that I don't actually have enough members. I can do 1, 2, 3 panels, but nothing else. But one of the things I can do is I can add a dummy member. So I can add a dummy member between those two. And here's where I start to get smart. So I can now create that panel. I can add a dummy member with a right mouse click between those two. And that allows me to create that. Now out here, I actually have a wall along here. So I'm going to do a little trick. So I'm going to add in a dummy member. And I'm going to go from here. Yep, snapping to that point. That's good. And then I'm going to do a right mouse click and add a dummy member from here to here. Right mouse click, add dummy member from here. Yep, that's good. Add dummy member from here to here. And I actually have a wee extension out to this side that's not supported directly, but the wee roof will be supported by some sort of glazing or a wall out here. So I still need to mimic that 1/2 meter of loading that's going to come back onto this beam to be correct, as we engineers are. So add dummy member from here, and I'm going to push it out by 1 meter, and then right mouse click, add dummy member from there, hover, right mouse click, add dummy member there to hover. So now I've got all my framing up. What I now need to do is put this internal spanning, so from here to here to here is all with the basic loading spanning that direction. So what's going to happen here is that this load will come onto this dummy member, and from the dummy member it'll run back to the 2 nodes, and of course that node's got a support on it anyway, and that node will have a support on it, so that will then just be forgotten about because it's looked after by the wall that's underneath, and we're not designing that. That wall actually already exists anyway. So the next thing I want to do is the outer bit, this extension bit. So I'm going to add, that's the inside, and then what I'm going to do is I'm going to add another one called outside. And then I'm going to come along and highlight these. And of course they're now spanning the wrong direction. Well, that one's spanning correctly, that one's not. I could change the direction, so that one's now wrong, or I could just say, go on, use the shortest, and in this case it works. I do have the facility, obviously, to override any of the panels and override on that panel, say for example the direction. I could have changed it so that that direction is XX or YY or back or not override, so it's now working properly. So those are all going to track their loads, but in this case I want to change the loading. So we're not making channels, so we're now doing an override load, and the override load is quite interesting. It's a lighter live load, but it's a heavier dead load because of the tiles. So the dead load is 0.6 kilonewtons per meter, and the live load is 0.75. So that's on that. So if we look at our areas and draw both of them, draw all, we will see they're different colors, and we will see, yeah, that'll do it. There, we'll see that they are different intensities and spanning different directions. So all we need to do now is to stabilize all these dummy members. So we can do that quite easily by adding in some more of those static supports. So if we run down to our fixities, we need to put a dummy support here, here, and here, and everything else is then supported directly or transferring to another member. So that is my area loading. The next thing I want to do is to apply the 2 wall loads. So if I have 2 wall loads here of 10 kilonewtons on this one and this one from the walls above. So under loads, line loads, and I'm going to say in apply mode, I'm going to call them just walls. I'm going to apply it there and there, and I'm going to say it is a dead load of 10 kilonewtons. There it is. And then what I'm going to do, it wouldn't even matter if I put a wall load on that one, because it's going to go from the dummy member straight down into the two fixed supports which simulate the wall underneath. I'm going to add another one, and this is going to be wall and roof, and this one is going to be all the way along here, 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 and here. It never draws anything until I start to put values. So I am going to put 14 and, I'll make it 15 actually, and 4 for the live. So it's getting a 4 kilonewton live load coming onto this wall and down onto the beams, plus the self weight of the wall, plus another 5 kilonewtons for the dead load of the roof structure as well. So now, what have I got? I have, in essence, all my loading applied. What I now want to look at are loading cases. Because I'm doing domestic, I don't want to have too big of deflections. I want a dead plus live service case. So I've got automatically the 2 cases here, and you will see that it's 1 and 1.35 as our standard Euro code information. And what I'm going to see is that it is going to add another one of those. So I'm going to come back to the cases, depth plus live ultimate, and just say add service. So it's going to create me a serviceability of 1 and 1 for the dead and live. And because this is in a small domestic, we don't need to worry about any stability, because it's all going to be attached to the walls and bracing, and it's not going to go anywhere. So it's just all vertical loading I'm interested in. So the next thing, you would normally run along now and design it, but I want to take a step back before I design, and I want to create some groups. Again, a pro feature that is now available in PowerPad Plus. So I want to take 3 columns are here, and I'm going to go in this case for 1.5L, although it won't really make much difference, and it's actually going to be a simple construction. So I'm going to put a K factor of 1.5 and 1.5 into those. So those are there, and it's a small job. I'm going to ask them to be the same section size. So those 4 sections will be held together. And now I want to take and create another one called small walls. So that's going to be for this member and this member. And I'm going to say these 2, they have everything spanning onto them, so they are going to be fully restrained. And I also want to set the deflection limit, and I'm going to use from the table type 1, which is internal 360 live and 250 dead and live. So we're covering it because dead is more critical quite frequently in domestic situations. And we're going to set a maximum depth. I can tolerate a 203, so I'm going to set 225, and I want both of those to be the same section size. Now also they have loading coming up on them, which we'll look at in a minute, from the walls. So I'm now going to do the other one, which is the big walls. And I'm going to take this one, and this one. and I am going to say that it's actually unrestrained because it's running in the same direction as the floors, so I'm not going to rely on this stabilizing it. So I'm going to say it's 1L, and I'm going to say it's restrained at incoming members. So yes, so this one here, which is longer, will be restrained by this. Or we can say no if you want to be more onerous, play safe. I can say no. Again, deflection limit I'm going to set as table 2, and the maximum I'm going to set as 225. So done those, done those. I'm now going to come along and add in a group for my front members, and they are going to be that one, and that one, and I'm going to just say they are going to be 1L and leave them at type 2. Now, same section size for all of them, and again I want to keep them smaller, so I'm going to set the minimum maximum depth to 175. I always go slightly higher than the section, 152, because 152s are slightly bigger when you get into the heavier weights, so I can tolerate up to 175 depth, so be realistic about that. Now, if I move back, I forgot to set these to be the same section size. And then finally, ties. And I am in ties going to choose this one, and this one. So they're little ones. That's obviously part of the big member. And you don't really need to set anything in those because they're very lightly loaded, and they will come in at to be 152s, or we could go in those cases for a UB instead if we want to keep them in smaller situations. But perfectly honest, I feel that you'd be better just sticking to the same type of section. So that's my beams and my columns all set up. Where does that help me? Well, when I go into design, steel member design, you notice all the dummy members are now dropped out. You don't see them. Space frame, at 100 members, and automatically I suddenly have all the design checks here for me, and I can see that my initial 152 isn't going to work. So let's go for lightest and auto size, and it's coming up at a 203 here. Now that's fine for that one, and that's okay for that one. What about these members here? If I auto size, it just about works for that. Now, if I was to come down to the 37, we just have a slight deflection problem. But if you can imagine the deflection itself wasn't the problem, we also in these members, because they aren't really restrained, they're destabilizing, and since we're using Eurocode and we're going to use a 203, we're going to be at least 100 mil above the center, the shear center of the member. So I put in 100, and perfectly honest, I always like to use the extra 50 that you would do in horizontal as well. I don't see why you shouldn't. So I can put a eccentricity in of 150. That means that not just deflection, but the rest is now a problem, which means that we do need to go up to the 46. So destabilizing load, it still works. And these now work. And what about these ones? 15223s are fine. You could possibly think about reducing those in weight by going to a UB if you want to bring in more section sizes. And 15289, because we've said we can't go above the 200 or thereabouts, we would put those in. So similar, slightly lighter. Now my columns, again, I'm seeing that a 100 by 3.6 works. It doesn't work here by 40% because that's carrying the biggest load. So moving up one at a time, we will find that the 120 by 4 works. I prefer a 5, so I'm going to go up to the 120 by 5. Now, I've set some limits externally. I can also set other limits by using something called a section filter, and here I can turn around and I can say that for square hollow sections and everything, I want at least a 5mm wall. It just saves hassle. Whoa, did I say 5mm? What did I just do? That's interesting. T-min is 5. Oh, I think it just dropped out the 4mm and went to the biggest section. It's just plain sillies. But you should find that we... Oh, close that. Yeah, we still have all the sections, but at minimum 5. So auto size that, and we'll come up to it being within 5%, and it's saying, are you okay at that or not? I'm going to say no, no, no. I want to go to either the 100 by 6 or 120 by 5. So I think the 100 by 6 will be good enough, and it keeps it inside the brick. So there we go. That's my steel members. And naturally, I could have done them all using the auto design and design them all in one go. But what I'm going to do now is just scan for any failures, and everything says it's clear. I'm going to reanalyze it. Not important here because nothing is indeterminate, so there will be no failures due to changes unless the self weight has suddenly changed drastically, but they're all fine. And we will see the unity values for all the sections with these wee ties taking absolutely nothing. Did I size those? I kept them the same, but they clearly again could come in as the wee UB joists at 152s to save yourself half the weight. Since those are going to be joists, those can be the same. So that's my steel done. Now, the next thing I want to do is to design my connections. And before I design my connections, I'm going to create some connection groups. So I am going to say that I have beam to beam flexible here and here and here. So I'm going to say, let's go in and apply that there and there and there. And you don't really need it over here because they're, well, you do, I suppose, to an extent, but because they're just bearing onto the pad, that's just going to be one member, hopefully, and that will just join into it. So you wouldn't need the joint there, but you need it there and there. And if I go ahead and I just call that beam, and then add another one, and this time I'm going to do a base plate, and I'm going to add them all in. So we're designing all 4 of them in one go. Sounds reasonable. Call that base. And then I'm not going to do them all, but what I'm going to do is I'm going to add on a third one, and I'm going to take this joint here, and I could add in the others if I wanted to. Actually those are the simple ones that can all be done together. This one, even though I choose it to be in the same group, it will actually refuse to be in the same group, and that is going to be a simple beam to column fin. So beam to column fin is there, base plates at the bottom, beam to beam flex, and back again. So we've got 3 sets of joints set up for us. We don't need to do them all today. Now I go into my steel design and reanalyzes, and it's just going to ask us some basic information, and I'm going to say yeah, happy, and I'm going to go for a simple connection, and let's just do the base plates first and say OK. So when I choose this base plate, the others will be highlighted with it, except for this one. I think I must have missed that one in the groupage. What I'm going to do actually is I'm just going to come here, and sometimes it's better to work in wireframe so you can see the colors better. Yep, that's better. When we release the 2018 version itself, you will actually have a newer graphical display which will give you more clarity. So my base plate, first things first, let's come in the 100 by 100 column. Let's go and make it a 300 by 300 base. 300 by 300. And immediately everything's okay. I don't think we need a 20mm plate. I'm going to go for a 10mm plate. And those bolt positions are okay, but if I want to be more practical about the thing and give more stability to the system, I would say that I'm going to go for an inner edge distance of 200, which gives me 50 edge in each direction, and then to the other one, right group, exterior, 200. There we go, all set out, all fine. Let's look at our next joint, and I am just going to turn off that bit, come back here, add another joint. It's going to be a simple connection, and it's going to be the beam to beam flex. So I'm going to go for the beam to beam flex at this point. So it's going, oh my goodness, I cannot work, I am in trouble. And that's because the Green Book uses a standard notch depth of 50mm, which is lunacy. I'm going to put this down to 0. It says 23, so I'm going to say, right, let's go for 25. And let's now go for 25. So now we've got the notching that we need, but we're still failing in certain depths. We need a deeper plate. So we need to come along here and insert another row of bolts or deepen the plate. And I always find that the easiest is to just put in 2 rows of bolts, and it's now looking okay. I need to do that on both sides. So go up to the other side, 2 rows of bolts, and now the joint is working. Happy up here, happy up here. So there's that, and you'll find it's taking the forces from the similar connection as well. Then I add in a third joint because we did 3, and that is a fin plate to column, and say OK. And if I apply it here, it's going to be more or less okay once we get this extra bolt in here. But what I'm going to do instead is I'm going to reapply it to this one, and it is going to be much worse in its design. At this stage there's just too much on the screen. Let's look at these. That looks okay. We'll see that it is only the flange beams that are problematic. So let us move across, and the shear is slightly accurate at 99.256. Oof. We should really just put that to 3 significant figures. Let's go to the 2 in the other direction. We need to get into these wee 152 beams. We need to slip enough depth to get this other bolt, and it is a wee bit awkward, and that's one of the reasons we can get clobbered using these very small sections. We just can't get connections that work. So let's put in a depth of section. It's 152. Let's put in 100. That's not enough. 120, 130. Too much. 120. That looks about right. And the other thing is the bolts, we need to reduce the bolt center, so we can take those and pull that up to 50 mil apart, 2D, which is touching on the limits. So vertical centers 50, and that's now inside, but I then need to look at this other side and come down and do the same here. I said vertical centers 50, and I also said the depth of the plate was 120. So we're nearly there. We've got this integrity problem, and it's the beam integrity. If I come down and have a look, we will see that it's the bearing here. And we are at the minute possibly looking at tie force checks. So if I go in and turn off tie forces here, apply and close, in our case we actually aren't doing multi-story, we don't have a need for tie forces, turn them off, and everything works here happily. There is a wee dimensional problem, and it's to do with the edge distances of the bolts. So let me see top edge distance, bottom edge distance. So we just need to pull that up. So possibly work with 35 there, 25 there, and we might think about using 16 mil bolts instead. So change that to 16s. And suddenly with 16s we actually end up with a slight failure in the bolt group, so we probably do need 20s in one direction at least and 16s in the other, which is not something we can do at the moment. We assume they're all the same, so put that to 20, and we can just pull the edge distance up to make that better to have it. That's shearing down, so we're bearing on this. Better to have lesser at the top than the bottom, so we would pull that up to 30 mil at the top. But I'm not going to walk through and do that at the moment. I just want to keep going here on the system. So we've done our panels, we've done our beams, we've done our base plates, we've done our connections. What's next? The next thing to do in this job is the pads. So first of all, we're going to pluck a value out of the sky, and I'm going to say, oh, it's not brilliant. I'm going to go for 100 Newton safe working pressure. I'm going to have no cohesion for sliding. I'm going to have, okay, passive, I'm going to put in a 0. So I'm not going to take any passive. Bob style, there we go. Straight bars. Surcharge of, going to have no surcharge other than the soil. That will come from the height bury. So we're burying it 450 down, so it'll take the height of the soil on top to help stabilize it. In this case that won't matter a hoot because it's only axially loaded, and we're going to go for reinforced. So and it comes in with a default, which is 750 by 300 base, and everything is happy. We have no problems. This is a more critical one. That's the most critical, and it actually went up to 950. So what we would do here is we'd say, let's make this a meter, and happy days. So 950 pad there. Everything else can be 750s, and everything's good. And we're getting consistent bearing on the soil. If we look at the stability, we're up to only 18 kilonewtons meter square. We're up to that. So, we could try and reduce that so that the bearing in each of them is pretty consistent, but we would need to go to quite a large pad that we don't need. So I don't believe that there would be any mileage in that. Now, we can also do mass concrete. I can turn it off to say, yes, I want to use mass concrete. And now it looks at this distance and allows you a spread. So it's saying you have projections of 325. So I could reduce this down or increase this to a 325 or 350 deep pad, and 750 by 350 as a mass concrete pad will work. And that is that done. So you can make these mass concrete at 750 by 300 or 350 and keep that one as reinforced if that's what you need, and everything's done. So in 52 minutes we have managed to do importing from AutoCAD, adding new members, adding new columns, putting on our area loading, designing all, I think it's 15 members, designing nearly all the connections. There were probably 2 more we needed to design, and designing our pad foundations, all within PowerPad. So what I'd like to look at now is a wee bit of the reporting. So I'm going to come out of here and say yes. So there's 2 ways of reporting. There's just the normal way of going and printing out results. So I could just take this, turn on 3D, turn on my section sizes, and I could print that to printer straight off, print graphics, and then do the next stage and the next stage. Or I can go for creating a report using the report generator. Report generation. So if I go to report and report generator, I can start and build up a little set of outputs for myself as I see fit, and add them in, and say, for example, in joints, when I go to customize, I want all briefs, summary, and selected loading cases, and apply. So that's going to remember that. And member diagram, I want that member, and cancel, because it's not really member diagram. I want it will be graphical output. So I'm just going to remove that and go to graphical output and add, and then come in and say I want bending moment at those scales, and apply. But instead of doing all of that, just say OK. So it's now taken that set and brought that in. So we're going to have a snapshot. So it's going to try and generate snapshots for us, front, rear, est, and I'm going to add or remove snapshots. In fact, what I want is I'm going to just save that or close. I'm going to save the changes, yes. I'm going to create 2 snapshots. So right mouse click and add snapshot, and call it 3D sections. And then I'm going to take off this, take off the section sizes, go back to wireframe, because what the snapshots do is they record everything that's on the screen here. Back to wireframe, don't need my nodes, and I'm going to go for black and white. So black and white, and I'm going to save this as my other, and even zoom in a wee bit first, snapshot, and add snapshot. Call it 3D wire, and save. So if we come back to our results in our report, which you've got here, we can say we first of all want it to display not that one, but the full 3D add. So I'm going to give a full 3D view and apply. And then for the frame load diagram, we're going to use Alt Dev plus Live Ultimate, and we're going to use the 3D wireframe as my snapshot. So I'm going to take this one out and add in, because the snapshots are dependent on the project. They're for each version. And we'll go for distributed loads and point loads. And we will have FEA surfaces. We'll have basic wind loads, line loads. And just say apply. And then graphical output, we can select the loading cases we want. And we're going to go for a snapshot that is called 3D wire, and add and apply, and just say we want, in fact, yep, that's the one, apply. Another graphical output for deflections, loading case is correct and I want 3D wire, add, and say apply. In fact, it's deflections, so I would choose dead plus live service as my output and show values and say apply. Then steel design, I'm going to come in and give all the loading cases, and I'm going to do the critical for each and only critical portions, and just print the summary. And then the second one is all the detailed outputs for, again, just the critical sections. So critical sections in each group apply. Very simple. Connections is, as we said earlier, full and graphics and summary only. Apply. Concrete design is going to be the full, and all I need now is to set up where it's going to go, in my case PDF Creator, save, and now I can sit back and generate the full set of information coming out, running along, going to the PDF writer. As we can see, we've done 3 pages so far, and how it's going and putting out the rest of the design checks. And now it's ready, and I'm just going to put this into my desktop, always the best place to put it, so that I can just delete it afterwards. And say save, replace, save, off it goes, and here we go, in it comes. There's your initial drawing, there's your loading on the structure, there's your bending moment diagrams, there's your deflected shapes, there's your summary results giving us all the passes, and then there's the detailed 1, 2, 3, 4, 5 connections, 5 members done, and then the connections 1, 2, 3 connections, and finally 4, the base plate. So all done automatically through a report generator, with a lot less work involved by you. And I'll just close. So ladies, gentlemen, one and all, I'd like to thank you all for attending today. If you want to try the PowerPad, just go onto our website, MasterSeries.com. Just go to PowerPad, and then just start your trial and request a free 14-day trial. If you're a student or a lecturer in a university, please feel free to download the student edition. And the student edition is free and you can download it. Restrictions are interesting. Obviously we tell you that it's for educational purposes all over the output and on the screen, but also the data files are not compatible with the commercial version. So if you're a practicing engineer and you want a second copy, this will not work because the data files are not compatible. As an addendum to this webinar, I would just like to demonstrate the use of wind analysis inside PowerPad. The 2018 versions of PowerPad will allow you to do wind analysis up to 100 member frames. So here's a little frame. It's like a little three-story house with a pitched roof and a balcony at third floor level. So just going into loading, we can go into wind panel loading, and the first thing we'll do is we'll set our directions we want to consider, and we'll just ask to consider all 4 directions since the frame isn't symmetrical, and we will ask to use master key wind analysis. And then moving forward, very simply, we would look at any global reductions, and since this is a small frame, we don't need to look at any reductions. Site data, we can choose any site in the UK or Ireland. I can switch over to the Irish maps or back to the UK. And for the UK, we can actually choose a location. So if we come in, we can choose a location here, or what we can do is run to a little website called Grid Reference Finder, and if I just zoom in on Norwich, I can find my location from postcodes, or in this case I'm just going to go and say that it's in here off the ring road. So we're going to put a pin there, and then we're going to grab this 6-figure grid reference back to MasterSeries, pop that in, Control V, and press enter, and now it's located there, and I just lock down that site. And the only other thing I need to do here is to rotate everything so that I have the right orientation of building to the north, and then just check back as to my method is the Eurocode method. I'm going to go for the designer's method with Eurocode and exit from that. So that's the wind basic pressures set up. We know what the wind pressures are, the basic pressures for each wind direction. We now need to create the panels and work out the coefficients on each of the panels. Again, very, very straightforward. Under loads, wind panels. We just define the panels very straightforwardly. So if I was to come in, I could say that is a panel, and I can say whether or not it spans horizontally or vertically, or two-way spanning, or even shortest. So I'm going to span this horizontally, and then I can't choose another panel because it's not on the same plane. What I am going to do is I'm going to kill that, and instead of going through them all one at a time, I'm just going to say auto, and the program will attempt to find all the panels. So let's color them up, and you'll see that these are identified as being parapets, and I just need to do 1 or 2 things. I need to go to this panel, and I need to tell it that it's spanning that direction, and I'm going to change my rafters to be spanning vertically through my trusses, and then just do this last one and vertically. So everything else here is working as we would expect, and they're all horizontally spanning. There's no reason why we couldn't have a two-way spanning wall as well. And that's it. It's very simple. Loads, we've specified everything. Bracing members, we didn't have any in this case. It's a fully rigid frame. But if there were any bracing members, just like in the area loading, we would isolate those so that they're not attached loading directly to them. Now, if we display, area loading, we get the little colors, but we can also see in any direction, W1. So there we go, wind blowing. And we will see that this is a higher load than here because it identifies it as being a parapet loaded on both sides. W2 blowing on side, W3, and then W4. So not very high loads because we are down in near the Wash in south of England. We also then look at the W1 but with internal pressure. So with internal pressure things got a bit less. And then finally internal suction. So things get a bit higher. And if we were designing cladding, we can actually ask for the maximum positive pressures and the maximum suctions, and we can see on any of the members what the maximum suction is on this surface. The suction is up to 0.732. So that's a wee quick run through the wind analysis for you, all part of the PowerPad Plus in 2018. So thank you again for viewing this.